I wanted to make a sand dune in lecture to demonstrate and explain the angle of repose, so I got some sand, washed it clean, and made sure that when it was poured onto a flat surface, it would pile up into a dune-like form that exhibited a natural angle of repose. The problem with this setup is that my students wouldn't be able to see very much if I simply poured it out from my position in front of the class. So I decided to make a home movie, and for that I would use my cell phone's video camera mounted on a tripod. My cell phone is the Samsung Galaxy S4, released summer 2013. I made a number of adjustments to default settings for better web streaming quality. The S4 maximum resolution is 13 megapixels, far too much for web streaming. Most recommendations are for 1280 by 720, or regular HD, about 2.5 megapixels per image. Because I draped black velvet for the background, I needed to override the auto exposure and reduce it by about 2 stops so that the lighter tones wouldn't be overexposed. I'm sure your cell phone camera has a number of controls similar to those. Playing with these settings can greatly improve the quality of your recorded video. My cell phone has a pretty good video camera, but the problem is that the phone can't be directly attached to a tripod. So I found an adapter on the web for about $14. To insert the phone, you pull apart the 2 clips. They're spring-loaded and rubber-coated so they won't scratch the edge of the phone or its case. Once the camera is inserted into the adapter, the unit can be screwed into a tripod with a standard 1/4-inch bolt. I found 5 of these tripods on the web for a total of about $7. Spread the legs apart, and the phone can be positioned in different orientations. So there you have it, a mounted cell phone video camera for less than $20. To make the sand dune, I got some gear from the chemistry stockroom: a ring stand, glass funnel, some clamps, rubber tubing. I mounted a ruler to put a scale in the video so students could estimate the size of the parts of the sand pile if this was important. I put a clamp on the rubber tubing. Then I put about 25 ml of clean, dry, medium-grained sand in the funnel. I found that this sand would pour smoothly through the narrow diameter. Then I set up the cell phone on its tripod, adjusted lighting, and shot the video. The first video shows the accumulation of freely falling sand in a pile. Before running the video, I give students a handout on which they'll record observations. As the pile builds, I tell them to make brief notes. I don't say anything about estimating quantitative measurements. However, I included the scale to make eyeball measurements possible. At the end of the video, I ask them to make a sketch of the pile and estimate the angle of slope. Here are a few examples. Details vary from extremely crude to some significant detail, and some students even included the scale. Some very interesting features can be seen here. Added sand doesn't increase the height much. Instead, the sand forms steepened sheets that chaotically slump. Here it is in slow motion at 1/4 speed. The analogy to me is channel avulsion in a delta, where rivers shift course to seek the steepest path to sea level. Very interesting and potentially productive of much discussion. We learned, and I suppose most of us teach, that the angle of repose for clean, dry sand is about 30 to 35 degrees. I never measured this in the field, but I did measure the slope angle on this image. I was shocked I was, that it came out to be almost exactly 35 degrees. Neat. Students could be given an image from the video, and after viewing it, asked to measure the slope angle to confirm this fact for themselves. There is a learning curve to produce good quality video from a late model cell phone camera. However, I believe video snips are only half the story. They need to be paired with guided viewing activities that require students to observe, describe, explain, predict, and exercise their higher cognitive processes. That combination, I believe, has greater potential to both demonstrate fundamental geoscience and engage students as they develop the critical thinking skills we value so much in higher education. So let's contribute to an open video archive for our profession. I'd be happy to help you with any assistance I can. Happy shooting. Bye. Scott Brandy here at UAB. signing out.